Today's question is, find the largest sum of a contiguous subarray containing at least one number within an array. For example, given the array -2, 1, -3, 4, -1, 2, 1, -5, 4, the contiguous subarray 4, -1, 2, 1 has the largest sum of 6. Before we get into solving the problem, let's write some test cases. I already wrote the test case given in the problem statement, but let's think of more. We should consider the case of an empty array, in which case we can expect a return value of 0. We should also test an array of length 1, where the return value is simply the single value in that array. And finally, we should also consider the case where the largest sum is a negative number. Now let's dive into the solutions. First, we can try brute forcing the solution. We can generate all possible contiguous subarrays, compare the sums, and return the largest sum. Let's code this. We should consider the edge case of an empty array, so let's add a check for that first, and return 0 if the given array is empty. Since the subarray must contain at least one number, let's initialize our maximum sum to the first number in the array. Now let's write our double for loop to generate all the subarrays. The first for loop will iterate through all indices. The second for loop will iterate from the value of the first for loop plus 1 to the length of the array plus 1. We start at the value of the first for loop plus 1 because we want to ensure that all subarrays have at least one number. And we end at the length of the array plus 1 because we will use this value to slice the list, and the stop value of the slice is exclusive. For example, if we slice a Python list from 1 to 3, we'll get the values at indices 1 and 2, but not at index 3. Now we'll set the max sum to the max of the max sum versus the sum of the generated subarray. We do this because we only want to update the max sum if the sum of the generated subarray is larger. Now we can return the max sum. Let's run the solution through the test cases. And it passes. Let's figure out the time complexity of this solution. We have a double for loop, each looping on the order of n times. Within this double for loop, our call to sum and slicing the array each take O of n time, which gives us a total time complexity of O of n cubed. This is not ideal. Let's think of a more clever solution. Let's see if we can do this in one pass through the array. Here's the example array given in the problem statement. Let's take a pass through this and see if we can find anything interesting. We have to start somewhere. So let's start by initializing the max sum to the first value, -2. Now let's look at the second value. If we take the subarray of the first two values, we get a sum of -1. But if we discard the first value and just take the second value, we get a greater sum of 1, which we can use to replace the maximum sum. Now let's take a look at the third value. If we add this to our current subarray of just the second value, we get a sum of -2. Now let's move on to the fourth value. If we add this to our current subarray, we get a sum of 2, which could replace our maximum sum. But we could also discard our current subarray and start again with just this value. which gives an even higher sum of 4. It seems like we're on to something. We build up a subarray as we traverse the list. If the current value is greater than the sum of the subarray plus the current value, we should just discard the subarray and start anew with the current value. This sounds promising. Let's try coding it. Again, we must consider the edge case of the empty array and handle that. Let's initialize our max sum and current sum to the first number. Now let's loop through the remaining numbers. We'll set the current sum to the max of the current sum plus the current number versus simply the number on its own. Now we'll set the maximum sum to the max of the maximum sum versus the new current sum. When we finish with the loop, we simply return the maximum sum and we're done. Let's run the test cases. And they pass. Since we have a single for loop with constant time operations within the loop, the time complexity for this solution is O of n, which is much better than that of the brute force solution. Thanks for watching the video. If you thought it was helpful, please leave a like. If you want to see more and get notified next time I upload, subscribe. I'll see you guys in the next video.